once we tell you to give differences, you have to draw a table of distinguishing characters. A table of distinguishing characters. So, what can you say about mechanical waves? Oh, talk about the cause. How are mechanical waves caused? I mean, what causes mechanical waves? Mechanical waves, we saw that they are caused by disturbance in a media. Caused by disturbance in a material media. So we can put it down. Caused by disturbance. Disturbance in a medium. In a medium or a material medium. What about the other side of electromagnetic waves? These are caused by disturbance in a magnetic field. Disturbance in an electromagnetic field. Okay. Caused by disturbance in an electromagnetic field. Then you can talk about their propagation, that since these ones require a material media, so they cannot travel through a vacuum. So they can't travel through a vacuum. So can't travel through vacuum. So whereas these ones can travel, since they don't need a material medium, travel through vacuum. A vacuum, that is a space which is empty without anything. Okay, they don't require anything for them to travel, so they can travel through a vacuum. We are going to see that mechanical waves are a little bit slow. If you look at sound waves, water waves and string waves, you cannot compare them with radio waves. When somebody is at a radio station broadcasting, the waves being sent to a given master and then finally reflected, totally entirely reflected, up to the receiver where you are now going to listen this person. If he says that it is 3:30, indeed even on your watch, it will be 3:30. You see? So, which means electromagnetic waves are very, very fast. So these ones are faster, these ones are not faster, not very fast, These ones are faster, very faster. Okay, so there is a category, after talking about types of waves, we are going to see that waves fall under two types. We have what we call progressive waves and what we call the standing waves, or what we call stationary waves. So under progressive waves, again we shall talk about what we call transverse and longitudinal. So we are going to discover today that mechanical waves can either be transverse or longitudinal. We shall come to those terms. What is the meaning of transverse and what is the meaning of longitudinal? So these ones are can be both transverse and longitudinal. Longitudinal. Those are types of progressive waves. We shall talk about a progressive wave and get to know what it means. But electromagnetic waves are purely transverse. They are transverse. Okay, so are purely transverse. Transverse wave. They are purely transverse waves. We shall talk about that when we are in the types of progressive waves. We are going to see that these mechanical waves, they cause relative movement of the particles of the medium in which they are traveling or in which they are moving. Whereas the electromagnetic waves, they leave no trace of their passage. in the space where they move or where they travel or pass. Okay, so mechanical waves, okay, they cause relative movement of particles in the medium where they move, but no permanent displacement. You need to put that, no permanent displacement. No permanent displacement of the medium as a whole. No permanent displacement of medium as a whole. Whereas these ones, they leave, okay, no evidence of their passage. Okay, very true. Leave no evidence. They leave no evidence of their passage. Of their passage in the space. In the space where they pass. In the space where they pass. The reason why I'm writing on the board, I want you to get my clear posture. Write your own notes in your own, using your own hands. There is a way a hand communicates to the brain. So while writing, you are getting more than somebody who is just viewing. That has been proved by scientists. So make sure that you are writing, noting somewhere. These are very, very good notes, which you may not get easily somewhere for free. Okay, or at that price you purchase the DVD on. So write your notes, keep them. They are very, very good notes. I have ample time to explain. There is no stone I'm going to leave unturned. Okay, so leave no evidence of their passage in the space, they pass. In the space where they pass. In the space where they pass. They leave no evidence. So how many are these? 1, 2, 3, 4, 5. Okay, those ones are enough. They can be enough. Okay. We have seen that they don't require a material medium. Caused by disturbance in an electromagnetic spectrum. You can talk about a material medium, by the way. So we can come here, talk about material medium, steel, mechanical, and then electromagnetic. So, number 6, do not require. We are not talking about this. We are talking about the cause, how they are produced, each of them. And these ones are caused by disturbance in the medium. So, these ones do not. Oh, these ones require. The first ones are the mechanical. So, the mechanical require a material medium for propagation or for transmission. So, require a material medium. A material medium for transmission or for their propagation. For their propagation. Then these ones do not require. Require a material medium. A material medium for their transmission or their propagation. So being first we talked about it. We are going to see that mechanical waves, mostly their speed is very low. For example, sound waves do travel at 330 or 320 or 340 meters per second. Whereas electromagnetic waves, they travel at a speed of light in a vacuum, which is 300 million meters every second, which can be written as 3 times 10 exponent 8 meters every second. Can you imagine? That is the speed of light, very greater than the speed of sound, because sound is an example of a mechanical wave. Sound cannot be produced in a vacuum. It needs a material medium. Now, what about the similarities. A person can tell you to talk about the similarities of these waves. The similarities between mechanical and electromagnetic waves. So what are those similar features? According to the way we have defined electromagnetic and then mechanical waves, what are those similar features, dear viewers? Oh, they both carry energy. Good. From one place to another. My student has answered that. Good. They both carry energy. They both carry energy from one place to another. That is good. Then we can talk of interference. This phenomenon, we shall talk about it in the future. Interference of waves. Among the wave properties, we shall have interference. So we can note it at the moment, but you put a star, we are going to give a detailed account for it. So they both undergo interference. So they both undergo interference. Interference. Then lastly, we can see, so they can both be deflected. So both can be, let us first talk about reflection. Both can be reflected. Yes. Also both can be reflected. And then finally, both can be deflected. All these are wave properties. Remember in our preamble, at the beginning, we stated the course outline, and we clearly said that we shall talk about the properties of waves, or wave properties. Some of the properties are here. So we shall give a detailed account of the meaning of reflection of waves, refraction of waves, diffraction of waves, interference of wave. So these are some of the properties between mechanical and electromagnetic waves. Remember, this came as a result of wave motion. We said wave motion is of two forms, mechanical and electromagnetic. Now this takes us to what we call the types of waves. Types of waves. Okay, types of waves. Types of waves. So dear viewers, how many types of waves do we have? Oh, the internet will tell you 3, will tell you 4, will tell you 5. But we have two major types of waves as general. And these types, we have what we call a progressive wave. A progressive wave. Or progressive waves. We can talk of progressive waves in general, not only one. Progressive waves. So, standing waves. Standing waves. These are also known as stationary waves. Stationary waves. So those are the two types of waves. Now the question is, what is a progressive wave and what is a standing wave? So we are going to discover today that a progressive wave is a traveling wave as a result of continuous disturbance. Oh, let us put that down. Definition. Definitions. Okay. We are talking about a progressive wave. A progressive wave is a moving or a traveling wave. Oh, progressive wave is a traveling. It is a traveling wave. As a result of continuous disturbance. Continuous disturbance. So that is a progressive wave. We shall give examples because we are going to talk about this in general. These are just definitions. We wanted to first define, then we go and talk about a progressive wave. So what you normally find on internet and even other resourceful books, you always find there are two types of waves. But those are not just types of waves, they are types of progressive waves. So such authors, they need to put this into consideration. And we are going to talk about those types of progressive waves, which in most cases are regarded to as the types of waves. No, that is not true. The types of waves are two. The progressive waves and then standing waves, or what we call the stationary wave. Then these are also broken down into other types, as we are going to see. So dear viewers, what about a stationary wave? What is a standing wave? We are going to see that a standing wave is a wave produced when two waves of equal frequency and nearly equal amplitude, traveling in opposite direction, do superimpose or interfere. We shall get to know those words. What is the meaning of superimposition or superposition? And what is the meaning of interference? At the moment, you can take the definition that a stationary wave or a standing wave. Let us use a stationary wave. A stationary wave. A stationary wave. A stationary wave is the wave produced. A wave produced when two waves of equal frequency, and amplitude, or you can talk of nearly amplitude. The amplitude may not be exactly the same. The amplitudes may not be exactly the same. We shall talk about the meaning of amplitude. We are coming to that. So, when two waves of equal frequency and amplitude, but you must have heard about maximum displacement of a particle from rest position. That's what we call the amplitude. You must have heard of frequency as number of oscillations made in 1 second. That is frequency. We shall talk about it in details under the terms used in waves. So, equal frequency and amplitude, traveling, they should be traveling in opposite directions. Traveling in opposite directions, interfere, or superimpose, or superpose. Other people use the word superpose. So that is what we call a stationary wave. So a stationary wave is the wave produced when two waves of equal frequency and amplitude traveling in opposite direction, traveling in opposite directions, interfere, or what we call superimposition. Another person can define a standing wave as a combination of two waves moving in opposite directions, each having the same amplitude and frequency. People can talk about that. For example, waves which are got from plucking a guitar string. A plucked guitar string will produce what we call a stationary or standing wave. Waves in open tubes due to an air column. Actually, we have to talk about that. Let me give you examples. Before I even forget, I may forget those examples to give them to you, yet they are very, very important. Even the definition of standing wave, you may open books when you don't have it. Let us first give alternative of a standing wave or a stationary wave. A stationary of A, not of E. Stationary wave is a combination of two waves of the same frequency and amplitude and amplitude. That is very true. two waves of the same frequency. What are we trying to mean here? If you have a wave A is traveling from point A to point B, this is A, and then you have another wave B traveling same amplitude, same frequency from point B. This is the direction of travel of this wave, whereas this is the direction of travel. They are traveling in opposite direction. Is the combination of two waves of the same frequency and amplitude traveling. This is a marking point. Traveling in opposite direction. So such waves which are of the same frequency and nearly equal amplitude can also be referred to as coherent. Those are coherent waves. They are produced by coherent sources. We shall talk about that in physics. When you go to A level, that's when we shall talk about that. So examples are of standing waves or stationary waves. Examples of stationary waves are, okay, we have already talked about plucked guitar string. Plucked guitar string, plucked guitar string. The waves produced are going to be stationary waves or standing waves. Also talk about waves produced in open tubes. Waves in open tubes. Or waves due to an air column. Okay? Waves due to an air column. You'll get to know everything about an air column. Now, since we have run out of space, allow me go and introduce the progressive waves, their examples, and then their types. Immediately after clearing some space. Don't go away, stay tuned. Yes, dear viewers, we'll be back from the break. It is still your teacher, SULAIT. So we have now gone to the types of progressive waves. And we are going to categorize progressive waves into what we call transverse waves and then longitudinal waves. Now, let us go and talk about the transverse waves. Definition and then their example. So dear viewers, what is a transverse waves? We are going to discover that a transverse wave is the one where particles of the medium vibrate perpendicular to the direction of travel of the wave. Let us first write this and then demonstrate. This is a wave. This is a wave where particles of the medium vibrate. I don't know whether people know the meaning of vibrate. I explained the medium, then vibration. You have ever had a phone, it vibrates, like shaking. That's what we are trying to mean. Some displacement of particles. Particles are being displaced from rest position. It's what we call vibration. However, this displacement is just a temporary displacement for a wave. Particles go back and settle back to their rest position. So, where particles of the medium vibrate perpendicular to the direction of travel of the wave. For example, take a look at this diagram. Assuming you had a wave, this is a wave which is maybe produced by a rope. Okay, so this wave has maximum displacement, minimum displacement, like that. It is a traveling wave. it is a progressive wave. Now the direction of travel, assuming it is this is direction of travel. Direction of travel. And what we have done here, we have drawn its displacement, S in meters, against time to bring out this outlook. As time is passing, how far is the wave displaced? We are going to discover that particles are going to be vibrating perpendicularly at right angles. If you look at the particles at this point, they are going to be vibrating at right angles. Look at them. Look at them. Look at them. Look at them. Like that, at right angles. Look at these ones. They are changing direction. But if we elongate this, it is going to be making 90 degrees with the direction of travel of the wave. That's what we mean by transverse waves.